Okay, morning everyone. Welcome to lesson 3 for week 1 for the specialist mathematics course. So today we're looking at how we define polynomial functions. Okay. So before we get started, could you please, firstly, just check in your notes, just check in how you are going 1 to 5. I will be on a live session shortly. So once you finish watching this, just come on the live session for a Q&A, and I'll check in with you there. So use the box method to expand these following expressions. Let's have a go at that. So with today, we're looking at what polynomial is. So polynomials, the coefficients, which in this case is the a, always have to be real numbers. So we don't want any imaginary or complex numbers in a polynomial, because polynomials are drawn on the real plane, which is as the Cartesian plane. Exponents always have to be whole numbers and positives. So no -1, no to the power of a half, anything like that. And your domain, which we've looked at what the domain and the range are of functions, the domain has to be all real. Okay. The range can be imaginary, and sometimes if you've ever tried to find the x-intercepts of a quadratic that doesn't actually hit the x-axis, you'll notice that using the quadratic equation, it'll ask you to find the square root of a negative. That's a good indication that the x-intercepts aren't actually real, they're imaginary. But the domain is always going to be real. So these examples here, so two left polynomials, they are polynomials because the coefficients are all real and the powers are positive and whole numbers. Now you might notice that this is fx here. If you haven't come across that before, fx just means a function of x. So fx and y pretty much mean the same thing. Okay. So most likely we'll be moving away from using y equals and towards fx. It's just when we get into more complex stuff, the fx is going to be a bit more useful. Okay, so there's a number of ways we can define polynomials. So if we define polynomials by the degree, which is the old computer. If we define them by the degree, so we look at what the highest power is in the polynomial. We can also do it via the number of terms, so the number of different things that there are in the polynomial. Okay, so with this here, the degree, the largest power is 3. So it's the third degree. And there are 4 terms. So there's 5x, 2x squared, negative 6x to the power of 3, and 3. Those are 4 separate terms. Okay. The degree of this polynomial, the largest power is 5. So this is to the 5th degree. And there are still 1, 2, 3, 4 terms. So remember our index laws. If something is multiplied, so 2x to the power of 3 times 4x to the power of 5, we add these two powers because they multiply by each other. So 3 plus 5 is 8. And looking here, also here there will only be 2 terms, because once we multiply this out, there's only 2 terms. And here we have the power of 12, so therefore this is the 12th degree, and there are 1, 2, 3, 4 terms. So, there we go. So we have a number of different ways of describing a function. Go away. A function based on the number of terms. So monomial for example, would be y equals x squared. That's only one term. Binomial would be something like y equals 2x plus 3. That's got two terms. Trinomial, which is basically what we've been doing with quadratics, x squared plus 2x plus 1, that has three terms. And polynomial is anything, polynomial is just a catch-all term. Okay? So once we get beyond 3, we tend to call them polynomials, but polynomial is a catch-all term as well. God, that's annoying. All right. All right. Well, that's annoying. So looking at these different polynomials, so 5 doesn't have a power, so it's to the 0th degree. It has one term, so it's monomial. This is basically, if you go through this, you'll get a good idea. I explained it relatively thoroughly just before. Okay, so for your exercise, I want you to draw up a table and I want you to work out these 5 polynomials, work out whether or not they are a polynomial, and then if they are, what the degree is, and then how many terms there are. And after we've done the last session, if I could just get you to write a single m-dash sentence describing this polynomial and have a read of this text. So if you've got the PowerPoint, that would be quite easy for you. I just want you to summarize this formula in one sentence. It can be any kind of sentence you like. Okay, so by now I should have already seen you in the live session. So have a good weekend.